Here's a thought experiment that many people whisper but few explore to the end. What would really happen if we took every nuclear bomb on Earth and set them all off at once? Stick with me. We'll walk from curiosity to clear explanations and end in a place of jaw-drop reflection and a practical takeaway we can carry into the real world. If big what-ifs are your thing, tap like and subscribe now so you won't miss the next one. First, scale. Today's world stockpile is on the order of many thousands of nuclear warheads, roughly 15,000 if you round. Most are held by 2 countries, with the rest spread among several others. Numbers change over time, but the point is simple. Humanity has built more destructive power than any previous generation could imagine. So how much power is that really? Picture all the cities on Earth with at least 100,000 people. There are thousands of them. On average, it would take several modern warheads to erase a big city completely. In other words, the existing arsenal is more than enough to destroy every major urban area on the planet and still have weapons left over. That term you sometimes hear, overkill, isn't poetry, it's arithmetic. But we're not here to talk about war. We're going to put every device in one remote place and detonate them together. Not because anyone should, because understanding the physics tells us something about our world, our limits, and our choices. Choose a location far from people, like deep in the Amazon rainforest. Stack the warheads in a single tight cluster. A typical modern warhead has a yield around a couple hundred kilotons of TNT. Multiply by all of them and you get a combined yield of a few gigatons. That's a number so big your brain slides off it. So let's anchor it. The volcanic eruption of Krakatoa in 1883 was one of the most violent events in recorded history. Our single combined blast would dwarf it many times over. Now, push the button. In the first instant, a sun-bright fireball blossoms, tens of kilometers wide, vaporizing everything at the center. The shockwave stamps outward faster than a hurricane can howl, flattening thousands of square kilometers of forest in a single breath. Within a few hundred kilometers, anything that can burn, burns. The sound is not just loud, it's global. Pressure waves would circle the planet again and again for days. A tower of ash and vapor, what people call a mushroom cloud, rises all the way into the stratosphere. Millions of tons of scorched material are thrown skyward. Fallout, dust and soot begin their journey on the winds, spreading out over continents and oceans. Down below, the blast leaves a fresh scar, a crater many kilometers across, ringed by an inferno the size of small countries. Radiation near the site is instantly lethal, of course, and a wide region downwind becomes dangerous for a long time. Worldwide, the total amount of radioactive material in the environment jumps. For most people far away, the main health effect wouldn't be instant death. It would be a small but real increase in long-term cancer risk. The climate does not shrug this off. Soot lofted high into the atmosphere absorbs sunlight. Global temperatures dip by a few degrees for several years. Growing seasons shorten. The shock to ecosystems is serious, but not necessarily the end of civilization. Painful? Yes. Apocalyptic for all life? Not quite. So far, we've detonated everything that exists. But let's push this thought experiment one step further, because this is where the real awe and the sober lesson lives. Imagine humanity mined enough uranium to build not thousands, but millions of warheads, and we compress all that yield into one place. Think of an energy release comparable to the asteroid impact that ended the dinosaurs, except this time, it's our own doing. The sky doesn't just light up, it splits. The fireball rises so high it's visible from half a continent away. The ground behaves like a liquid, splashing outward and carving a crater on the order of 100 kilometers across. Whole mountains of bedrock are vaporized in an instant. Ejecta, red-hot fragments of Earth, are thrown into space. Some never come back. Most fall again as a storm of burning stones and glass that turn skies the color of rust. Where they land, they start fires. Not a few fires, firestorms that merge and run until there's nothing left to burn. The shock makes the planet ring like a bell. Earthquakes ripple worldwide, stronger than anything in human history. Winds with the force of severe cyclones tear across a continent. In places rich in hydrocarbons, think deep soils, peat and organic matter, the very ground feeds the flames. Now look up. The air itself has changed. Smoke and dust fill the stratosphere and spread around the globe. Sunlight struggles to reach the surface. Temperatures plunge toward freezing in places that should be warm. This impact winter does not last a season. It can last decades. Crops fail. Food chains break. For large animals, humans included, survival becomes a math problem with the wrong answer. Is there anyone left? Maybe. People in deep bunkers or submarines might outlast the first months. But the world they eventually step into is quiet in a way that hurts. A dim, cold, ash-grey planet sprinkled with radiation and stripped of easy food. A few pockets of life persist, but the old web of life, the one that fed us, has torn. And Earth? Earth endures. Planets don't panic. Give it a few million years and rain, wind and geology will erase the scars. New forests will grow where the desert's cooled. Somewhere, somehow, clever creatures may rise again. If they learn to read the rocks, they'll find a razor-thin layer spread worldwide, spiked with strange isotopes, rare elements, and tiny shards of plastic, the fossilized signature of an animal that learned to split the atom before it learned complete wisdom. They'll be puzzled. Maybe they'll be warned. What should we take from this tour? Not fear, perspective. We live in an age where our tools can move history in a single day. That means the most important technology we carry is not in a silo or a lab. It's in our shared choices, treaties, communication, restraint, and the stubborn human habit of building bridges when the alternatives are unthinkable. Knowing the physics makes the stakes visible. Knowing the stakes should make us careful. If this journey sparked your curiosity or gave you a new way to think about power and responsibility, please like the video and subscribe to the channel. It tells the algorithm to show this to more people, and it helps us keep making clear, calm explorations of big questions. Now your turn. Which impossible scenario should we dissect next? Drop your idea in the comments. We'll run the numbers, trace the consequences, and bring you back another journey of a few minutes from wonder to understanding, and hopefully to wisdom.